All right, good afternoon, everyone. Today we're going to continue or finish up the notes in 2-1 and 2-2. Now, we did the vast majority of actually the 2-1, 2-2 notes here, but to finish up today, we're actually just going to focus on one single concept here today. And it does take a little bit of work, and that's why I like to focus just one day of it. Okay? And that's this definition down here at the bottom of these notes that we have. It's what we call outliers. Outliers are simply what we call data points that are outside the overall pattern of the data. So we actually have a mathematical formula for outliers. So outliers, our formula for outliers, it's twofold. There's two things we have to do. What we do is, one of the things we do is we compare it to the third quartile and the first quartile. So what we do is we actually calculate out the interquartile range. So I know I'm kind of writing something ahead here, but we calculate out that interquartile range. Remember, the interquartile range is Q3 minus Q1. So we measure out the middle 50% of scores. We take that distance, multiply it by 1.5. We add it to Q3, and we subtract that value from Q1, okay? So if we have any data points that are greater than Q3 plus 1.5 times IQR, or values that are less than Q1 minus 1.5 times IQR, we consider those outliers. So visually speaking wise, kind of this is what we're thinking about, okay? Here's my, say if this is my box plot, okay? So the first thing I do is I calculate out this distance right here, okay? And we call this the IQR, okay? So then what I'm doing is I'm taking this distance, okay? And I might have 1.5 times IQR. So I'm taking 1.5 times this distance. Say if it gets me to here, okay? And I'm adding it to, here's Q3. So I'm adding it to it. Say if it gets me to here. Any value that's greater than it would be considered an outlier. So anything bigger than it. Likewise, if I take that same distance this way, that remember how this is Q1, and I subtract it. So if I go basically this distance, whoops, sorry, I just want to erase that little part because I'm kind of messing. So 1.5 times IQR. Whoops, I forgot the I. Wow, Mr. Parks, you've had two little typos here. Probably going a little fast. So notice how if I go Q1 and I subtract this distance, this is going to get me to here. So anything that's here are considered outliers. So now I purposely drew my box plot this way to show you that sometimes you don't have outliers on one side. Sometimes you do have outliers on one side. Sometimes you have outliers on both sides. Sometimes you don't have them at all, okay? So to show you and put this actually in context for you, if we take a look at going back to Connie and Oscar's problem, one of the things they asked you to do here is it says, determine if there are any outliers and then list them if there are any, okay? So I'm going to start with Connie. So when I do outliers, it's pretty easy to do. It's just a few steps. I start with the interquartile range. What was the IQR? So if I go back to Connie's data here just a little bit, okay, Q3 was 85, Q1 was 82. So I go 85 minus 82, and I get 3. So now what I want to then do is I need to figure out 1.5 times the IQR. So all I'm doing here is I'm going 1.5 times this value, 3, and I get 4.5. So now what I want to do is figure out the IQR boundaries. So if I go quartile 3 plus 1.5 times IQR, what I'm doing is I'm taking Q3, which was 85, and I'm adding 4.5 to it. I get 89.5. If I go Q1 now, minus 1.5 times IQR. So now I take the Q1, 82 minus 4.5 is 77.5. So technically, outliers are values greater than 89.5 and less than 77.5. So I go back to the data set and I ask myself, dude, I have any data points in Connie's data bigger than 89.5. Here's 89.5 on the graph, and you can see there are none. Less than 77.5, well, here's 77.5. Looks like I at least have one outlier for Connie. So if I go up to the data, the only data point that was even in the 70s was 72. So we have one outlier. So we'd say one outlier at 72. Look at that. Just like that. Got it taken care of. All right, let's do the same for Oscar. In fact, if you want to pause the video, try it yourself, then watch me do it. See if you got the connection here. All right, so if you pause, here we go. Here's Oscar. So now we start with IQR first. So I got to kind of scroll up for a second and look. Oscar's was 94 minus 76. Wow, this is going to be a big IQR. 94 minus 76. I think that's 18, but I'll just double check. I think that's 18. So now what I like to do is go 1.5 times the interquartile range. So 1.5 times 18 is 27. So now I'm going to go Q3 plus 1.5 IQR. So 94 plus 27. Wow, that's a big number. Let's see, I think that's 121. Then I do Q1 minus 1.5 times IQR. So 76 minus 27, I think that's 49. So outliers, by definition, for Oscar's data are values greater than 121 or less than 49. Well, if we look here, the max value was only 96 and the min value was only 72. So in Oscar's case, there are no outliers whatsoever. Okay? All right, so what's nice about your worksheet today is it actually does a nice review of finding mean, median, interquartile range, and all this. But a couple of your questions today are definitely going to ask you to find some outliers. So make sure you have a good understanding of outliers today. Again, email me, let me know. We can do Google Meets if you got any questions for today. But today's lesson was nice, short, and sweet. All right, see you tomorrow.